Why is screen scraping kind of going out of style? First, let's talk about what screen scraping is, and I'll talk about a lot of the challenges of screen scraping. But just big picture, if you are learning these techniques for the first time, and you are wondering how difficult it is to get up to speed in coding and extracting data from a website, screen scraping, though one of the more primitive approaches for collecting data, can also be one of the most frustrating and can be fairly unsystematic and difficult to do. And I'll explain why that is. So if you are getting your feet wet with digital trace data and you're having trouble reproducing what I'm doing up here in the next few minutes, don't worry, it's screen scraping, not you. Okay. So first, what is screen scraping? This is kind of a catch-all term, but broadly, the way I use it is to describe the process of extracting some type of information from some type of web page in order to create some type of database to study some type of social phenomenon. So we're going to use some silly kind of toy examples here today that don't really have much practical significance in social science, but you can imagine a variety of cases where you want to get some data. We're going to learn in the next section after the coffee break about a kind of much easier and superior, I think, alternative and perhaps more legal alternative, which is using these tools known as application programming interfaces. But I find that many young computational social scientists need to have screen scraping in their toolkit because there is, at some point in time, a challenge that involves extracting information from some type of web page. So the first question to ask yourself, we began to have this discussion a little bit when we talked about ethics yesterday. The first thing to ask yourself is the thing I want to screen scrape, can I do that? Is it legal? We discussed yesterday the terms of service of a website. These are the contracts we all adhere to and none of us read that describe the ways that the site is allowed to use our data. We also, at the bottom of many sites, can observe something called the robots.txt policy, and this is a set of rules about whether and how you are allowed to automatically scrape data from a web page. And in many, many cases, you will see that there is a problem, and I think we're having an issue, so I'm going to stop.
So we just had a live stream crash.
Oh, no.
So
Okay.
it's okay.
Okay. Interpretive dance. Part of it. Yeah, it wasn't live streamed.
We can take some questions now?
Sure, yeah.
Okay.
Yeah.
Mm-hmm. Yeah, I sort of had a question on the previous part. So it's sort of generally known now that these data are non-representative.
Mm-hmm.
Do you think it's still a good idea to always try and sort of validate your data against a sort of ground truth measure if you can? Or?
Yeah, absolutely. Yeah, I think wherever that's possible. It's not always possible, but like one of the things with like the Facebook advertising data, which I know your group has at Oxford has done a lot of work with, like comparing those to things like vital statistics data from national governments, demographic surveys by international organizations. One of the things that always bothers me about these types of comparisons, though, is I wonder if Facebook's own metrics are to some degree generated from these very same sources. Like if I were Facebook and was going to try to estimate the prevalence of poverty in a region, I would probably first go to the census to like calibrate my model before I started looking at features from my own platform. So I do worry about that. And so sometimes I'm a little skeptical when I see data that perfectly reproduces the data, the ground truth data. And like if we're being good, careful social scientists, we should probably be skeptical of like how governments produce data too. There's a lot of good work on census remuneration, which in this day and age has become a complicated subject even here in the U.S. But the way people are categorized, the way poverty is operationalized, the way things like gender are measured. I mean, all these things are kind of, so the concept of ground truth, I think, is kind of like a fool's errand. We really never have. We should be talking about the calibration of our measurements rather than some kind of underlying truth. That's my view. But maybe it's a little jaded. Yeah, Felix.
A very basic question.
Sure. Yeah.
Is there like a hard boundary between digital data and digital trace data?
Huh. It's a good question. For me, this is all kind of semantics. Like, I don't personally make one. I think other people might. So, for example, I think when some people use the term, they might refer to like wearable technology or something that's really like, you know, some type of like user-generated footprint. Like, they might not include administrative data in that category. For me, it's just kind of a catch-all to describe, you know, data that can be digitized that comes from some, you know, non-systematic data collection strategy that results from some kind of underlying human behavior. It could be the organization of governments and how they're, you know, tracking health problems or something like that. I consider that human behavior, even though it is arguably systematic. But yeah, I don't think, I think the trace part is something that some scholars, especially in STEM and engineering fields, might consider more associated with wearables, at least in a lot of the literatures I read. So that's probably the best answer I could give to that question. Yeah? Mm-hmm.
When do we have to apply for IRB? Do we just using API or scraping from
Mm-hmm. Yeah, everybody hear the question? When do you apply for IRB? It's a very good question, one that I get asked a lot. The very first thing I encourage students to do when they express interest in working with one of these techniques is to go to talk to an IRB officer. You know, as I think Matt made this point yesterday, I can't remember, Matt, like that we often are like kind of adversarial towards IRB, right? They're the enemy, they're stopping us from doing the cool research. Really, there are people over there who, you know, want to understand what we're doing and want to help us do the research ethically, you know? So having a very preliminary conversation about, here's what I'd like to do, here's how it would look like, I haven't yet written my proposal, can you give me any feedback, or can we talk about possible issues? And you may become aware of, the need to specify how you're going to store the data that wasn't on your radar. So it might actually help you write your IRB application. But I think many people don't have that initial conversation because they think someone's going to say, don't do it. We're back on. All right, good. Do you know where we lost?
Yeah, do you want to rewind just a couple slides?
Yeah, started screen scraping again. Okay. Welcome back, the rest of the world. Sorry about that. We still working out AV kinks here. And I'm just not quite sure where I lost everybody, but we're going to start over again with the subject of screen scraping, which I mentioned is a somewhat primitive form of extracting digital trace data from websites. And for those of you who are new to the field and getting your feet wet, it is also a particularly it can be a particularly frustrating form of extracting digital trace data for reasons that I'll soon describe. So what is screen scraping? Screen scraping, for me, refers to downloading the contents of a website, extracting or parsing through the contents of that website for some piece of information, and storing it into a database, often in an iterative fashion. So you're kind of going through and picking up data points again and again and again. And the steps typically involve identifying some type of page that you can legally scrape, downloading some source code, meaning the actual guts or contents of the web page, and then parsing through that and populating a data frame. So the first question that you need to ask is screen scraping legal? And what you want to look for in most cases is the robots.txt policy at the bottom of a web page that specifies the conditions under which you are allowed to automatically visit the site and extract information from the site. Once upon a time, it was kind of the wild, wild west of computational social science. Very few sites had stringent policies on what you could and could not do, and many people collected vast databases, including of some of the larger tech companies like Facebook. What happened? Well, in some cases, those data were eventually published as part of really great studies that came out in really great journals. But the far more common story, from my perspective, was that these studies got shut down in one way or another. So when I was a postdoc in Michigan, 2 members of the computer science department received a cease and desist letter from Facebook after they had scraped some 100,000 profiles from the site, right? Why was there this crackdown? Well, there's a few reasons. Now it seems obvious in the post-Cambridge Analytica, post-emotional contagion study, we all understand now that these data are very sensitive, but it's easy to kind of have this kind of amnesia about what it was like back in the wild, wild west, when really it just seemed like, you know, the more good content you could produce, the better. People hadn't yet, I think, realized the sensitivity of the data or the value of the data. And so many sites over time implemented increasingly stringent legal restrictions on scraping the site, which many people continued to ignore and continued to collect data. And that's a difficult decision that many people are forced to make. But as you consider making that, let me just give you another thought experiment, which is that, you know, you've spent 3 years carefully scraping data from a site that has a policy that explicitly prevents you from doing that. And, you know, it's the week before your dissertation defense and you get a cease and desist letter from that website, right? This is not a scenario any of us want to contemplate, right? Because it certainly could affect the publication process and so on. So we need to have better standards and better conversations. And I'm not a lawyer, you can't take legal advice from me, but I encourage you, just as I was encouraging someone here earlier, to reach out to your IRB officer early and often. Universities typically have an office of general counsel here in the States. I'm not sure what the international analogy would be, but these are people who are lawyers who work for a university who can help you read and understand these terms of service and can at least help you have some idea of the consequences of what you might be doing. So before you even think about screen scraping, consider whether it's legal. And what's important now is that it's not just the sensitive websites that have these restrictions. As technology for building websites scaled, the legal templates for specifying how people should use those websites also scaled, meaning that even websites that don't have particularly valuable or sensitive information may still have some type of restriction against collecting data. Okay, so screen scraping might be illegal. Screen scraping is also frustrating. One of the main reasons that it's frustrating is very often the site that you want to scrape is designed in a way to make it difficult to scrape the data. The data that you can clearly see in your browser is actually hidden somewhere deep in the guts of the website, in the source code, could be HTML, could be XML, and you have to learn how to find that part of a very long set of words and numbers that contains your data, and I'll show you an example in just a second. So if it's illegal, it's frustrating, and especially if your goal is to iteratively collect a lot of data across a lot of websites, you're not only going to deal with the idiosyncrasies of any single website as you go to scrape it, meaning how their web page is structured and where the information you want resides on that page, but then when you go to a wholly different organization's web page, they may have a totally different structure. You then need to write code that navigates that idiosyncratic structure too. And so say you wanted to scrape a lot of information from media or newspapers or some kind of online sources, you would be faced with potentially writing custom code to scrape, you know, a large number of websites. And those websites may change over time, and that might break your code. And so there's a lot of frustration in screen scraping. And again, I'm teaching it today to give you a tool in your toolkit that I think you'll use one day, but you may be much better served by application programming interfaces, which we're going to talk about after the coffee break. So the first step in kind of any screen scraping endeavor is to simply read your web page into whatever software you're using. Today and tomorrow I'm going to be using R. I'm not an R evangelist. If you use Python, great. Whatever language, Julia, great. Whatever language you prefer is great. My advice is to learn one language well. And I think for most of our tasks in computational social science, either R or Python will serve you well. But the first step in any screen scraping is simply to read a web page into whatever software we're using. For screen scraping, I prefer the rvest library in R. So if you've gone through our pre-institute training, you've hopefully by now learned about installing an R package. This is the code that would do that for this particular package, which was written by the famous R developer Hadley Wickham. but it's actually a kind of a repurposed version of the Python library Beautiful Soup for those of you who are Python users. And after we install the package, we need to load the package using this library function in R. And we're going to begin by scraping a very simple web page from Wikipedia. So if you are following along with me today, the links to these slides are in our Schedule and Materials section of the main Princeton page. They may also be on the page of your specific site if you're at one of our partner locations. And what I'd love for you to do right now is pull up a simple web page from Wikipedia that we're going to scrape together. I'm not going to click on this link, but I would like you to do so if you're following along. There's one more word of advice. There's an argument for not following along. If you are a learn by doer type, I would absolutely encourage you to start coding or open up your own session of RStudio to follow along. If, on the other hand, this is your first time encountering this stuff and you're new to this stuff, remember that for each and every section of the materials, both today and tomorrow, there is an annotated code document linked on the schedule. And that summarizes most, if not all, of what I'm telling you here and describes what each line of code is doing. So if you want to try to kind of let the big picture sink in and deal with the details later, we've tried over many years, and many people have now contributed to that code to make it better. And again, if you are an expert and would like to suggest improvements to the code, this is one of the great features of this community, that we can make everything better. And if everybody makes our code better, then everybody can use that code. So please, to the experts, if you have recommendations, please submit pull requests by going to the Summer Institute's GitHub repo. And we have a folder marked 2019 and a folder marked materials. And there you will find all the native files. These are .rpres files, which is a format for creating presentations in R. And then there are R markdown files, which link the annotated code. OK. So if you've now gotten to that web page, you're seeing something like this, the World Health Organization ranking of health systems in 2000. I've chosen a really arbitrary example, health and international health. And I've intentionally chosen what is a very simple web page. Wikipedia is a pretty miraculous, I think, example of an internet success story in many ways. And partly that's by being like lean and mean and having relatively simple and consistent code. So most Wikipedia pages we all recognize, right? There's a title, there's a subtitle, there's kind of a table of contents. You know, we can kind of see the content we need pretty quickly in the page. And that could be advantageous if we wanted to, for example, scrape a large number of Wikipedia pages because they're going to have a pretty consistent structure. It turns out that Wikipedia has an application programming interface, which is the type of tool I'm telling you that I'm going to talk about in a few minutes, which is probably a superior alternative for extracting data from Wikipedia, depending on what you want to do. But for now, we're choosing a simple example with a consistent structure to do a relatively easy form of screen scraping. So this is what the page looks like to us. But what the page looks like to our browser is this. This is the source code of this page. So if you want to view this in your own browser, if you're in Chrome, by the way, I should have mentioned most of my examples are going to use Chrome. I'll try to, if you're using Firefox or Safari or other browsers, I'll try to give you instructions for those browsers as well. But if you are choosing between browsers right now, please go to Chrome. And if you go to Developer, the menu at the top of the page, and View Source, from one of the drop-down menus, you should be able to see the source code of any web page. And what you're seeing here is, this is HTML, and what you're seeing is somewhere in here is the content of the web page that we might want to scrape. In our example, we're going to try to get a table that describes health indicators for a lot of different countries, and we're just going to try to pull out that single table, the data that describe each country's rank in all these measures. But you'll see up at the top of the page here a bunch of seemingly, kind of nonsense text. Some of this is doing things like defining the aesthetics of the web page. How big should the font be? What color should the font be? What font format should the page use? How should it be laid out, meaning where should different parts of the web page be rendered in a browser or perhaps on a mobile browser? And so there's a long set of instructions that your browser is using to figure out how to visualize the page to you. And the content we want is probably hidden somewhere deep in the guts of the HTML file. So what we're going to want to do is first read in all this data into R and then begin to parse it. And that means to use tools to try to figure out where the data that we want lives. So to download the actual HTML, the actual source code, we can use the read._html function from rvest. And that simply creates a new object that contains the source code. And in subsequent steps, we're going to try to parse through that source code to pull out the table of health indicators on that web page. And we're just here browsing to see what it looks like. And one of the first things we need to understand is that many web pages have a tree-like structure. Here we're looking at a common HTML structure, the head and the body. The head often reports the title and aesthetics, or sometimes known as CSS, as well as metadata about the page, maybe who wrote it, what organization created it, when, things like that. And usually when we're screen scraping, we want something that lives in the body of the page. That's kind of the content or guts of the page. And then within the body, there might be separate branches, paragraphs, headers, and so on and so forth, and subheaders and subparagraphs and so on and so forth. And we need to figure out where the table that we want lives in this tree. And so you can imagine how painstaking it would be to scroll through that long mess and try to find that data, especially because a lot of these data have a nested structure, which makes it really difficult to, say, use Control F to try to find the piece of information you want on that page. Fortunately, there are tools that run natively within browsers like Chrome that allow you to identify snippets of character strings that allow you to parse the HTML more effectively. So earlier I mentioned the wrong drop-down menu. It's the View menu that gets you to the Developer menu. And from the Developer menu, if you choose View Source, then you should be able to see the source code that I was just talking about. The next step, though, is to come back to the regular page and to click here on Developer Tools. And this is a neat feature of Chrome that allows you to simultaneously browse the web page as you see it, and then browse the HTML. And essentially what we can do with this tool is click on different elements in the page as we see it, and illuminate the part of the source code or the part of the HTML where the data we want lives. So in our example, we're trying to scrape the data from this table here that has health indicators. And so if we come in here and kind of mouse over here and begin to click and interact with that part of the page, we notice that it begins to illuminate a part of the source code here. And this is that nested structure that I was talking about before. And we can see here that the data we want live within this branch of the HTML. And if we right-click with our mouse, we can then choose Inspect. And if we inspect, we then are allowed to use this copy menu to copy something called the XPath, which is a character string that helps us parse the HTML. It helps us figure out which part of the HTML data contains the data that we want. And so basically a lot of screen scraping, one of the reasons why it can be very frustrating, is kind of going back and forth, interacting with the page to try to generate this character string which helps us parse it. But as you might imagine, you might click on one part of the page that is actually something else. So you may have clicked on the flag for Estonia or something like that, and then that takes you to the link to the image file that is storing that flag. You'd have to click somewhere in the middle of the table, perhaps, to activate the exact XPath that you need. But once we have the XPath, and again, this could take some time, especially for a much more complex site than Wikipedia, we can then use the XPath to navigate the object that we created in the previous step called Wikipedia page. So that's when we read in the source code. And now we can simply add an argument to the function HTML node, which is a function that helps us parse the HTML, find the branch of the HTML where our data lives, and read in the XPath. This is what I copied from the web page when I made these slides. And then I can create another object, which is the branch of the HTML, or the node of the HTML, sometimes we use the terminology node, where the data we want lives. I've called it, very arbitrarily, section of Wikipedia. Lastly, once we're in the right branch, then we can use one of the functions within rvest. Rvest has an HTML table function, which allows us to pull out any tables in one node or branch of the HTML. And so I've used that here to create a new object called health rankings. And in this last line of code, I'm simply browsing the first 2 columns, which describe one of the health indicators and the country. And if we wanted text, we could use the HTML_text command. But typically, we want either text or a table or an image. And the rvest package should provide you with a guide to extract any of those kinds of elements. So the real trick here is figuring out the XPath in order to pass that to this function. Or if you're in Beautiful Soup in Python, you're going to be using a very similar type of workflow. Unfortunately, very often, despite a good faith effort, the XPath does not produce the type of data you were hoping to get from the web page. And luckily, there are multiple ways to skin the cat, as we say in the States. No offense to cat people. When the XPath fails, this is very often the case when we deal with a more complicated web page. So I know as well as anyone that the Duke page is very complicated and difficult to navigate. And so I can say, if I wanted to get here, there's a part of the Duke page that's describing current events. And let's say I was, interested in creating a scraper that daily went there and grabbed all the events. I don't really know what the social science purpose of this would be like, but let's just say I want to do some kind of iterative data collection from the Duke web page. Well, this type of web page, you can see it's a lot more sophisticated than the Wikipedia page. Why? Well, there's a lot of interactive features. There's some JavaScript here, which is determining what happens when you mouse over something or interact with something. And maybe to produce the kind of data that I want, I might have to interact. That creates another layer of challenge when I'm trying to screen scrape. In this case, the data I want is hiding within a JavaScript or an element within the web page that will not be produced via the XPath. And here, a common alternative is to use something called the CSS selector, which is another type snippet of character string, which can be passed to the same type of functions we were using earlier in order to extract part of a web page. And the way that one can find the CSS selector is to use, one way to do it is to use this gadget or plugin for Chrome. And what this does is gives you a tool that allows you to, again, interact with the page by clicking on an area that you wish to scrape, then clicking on an area that you don't wish to scrape, then clicking on an area which you do wish to scrape, until only the area that you want to scrape is illuminated in green. This can be a very frustrating process and cumbersome process and deeply unscientific process, which is one of the reasons why I continue to say that screen scraping may frustrate you, especially as you enter into these more difficult pages. But after much laborious clicking, I discovered in this particular example that the CSS selector, which you can identify at the bottom of a page using the selector gadget here, it will appear here. You can also get the XPath through this tool if you prefer this tool to Chrome's tool. And then instead of passing the XPath here, I've passed the CSS selector, which is again this little piece of gibberish that tells me which part of the HTML contains this data from the Duke web page. I want to point out one more thing here, which is this is not quite the data we wanted. You'll notice we have these /n/t, etc. Why do we have that? These are known as HTML tags. These are instructions to the browser about how to, for example, indent some text or create a new line that we've accidentally kind of scraped. This type of HTML tag is kind of ubiquitous in a lot of digital trace data, sometimes even from APIs, depending on how the data are structured. And so we'll learn tomorrow about some simple tools to clean up these HTML tags. But if you're wondering what those are, that's what they are. And sometimes they can be easier or trickier to parse through. But it's yet another reason why you typically want to approach screen scraping. Again, if your goal is to scrape a lot of different kind of sites, now imagine how difficult it was to get data from one site that had a very consistent structure, and it was still difficult to get one that had a more complicated structure, but there are far more complicated sites than this that have legal restrictions that prevent you from collecting data from them, and that also change and have dynamic features that make it hard to scrape. And so you may find that, in a lot of cases of screen scraping, you may be much better served by hiring, for example, Amazon Mechanical Turk workers to visit a list of web pages and extract some information that you want, rather than writing a custom scraper that might take you days or even weeks, depending on the complexity of the task to write. But it's good to have in your tool belt, and in addition to these two techniques that we've discussed so far using the XPath and the CSS Selector, I'm going to go over one last tool for screen scraping. I'm going to suggest that you do not follow along with the code on these screens for a few reasons. The first is that this package that we're going to use, or this software that we're going to use, is called Selenium. It's a software that actually takes control of your computer in various ways, especially your browser. And so many people will be uncomfortable with that. It is recently approved by CRAN, the kind of central archive of the R community. But it has been taken off CRAN because of violations or kind of seeming vulnerabilities. So use it with caution. The other reason to proceed with caution is, depending on your operating system, it can create real issues with your operating system that might require you to install an older version of Java, which is part of the guts of most operating systems. And if you do that, your Selenium code may work, but other things you do on your computer may break. So I'm going to advise not to follow along. There are some slightly nicer hacks that I've built into the code here, which will hopefully prevent you from running into some of these OS issues. For example, using Docker, which is a tool that allows you to use a virtual machine to do this, or a virtual instance of a machine to do this. But you're still going to find that this can be tricky to get up and running. But browser automation can be a useful tool if you need to collect information from a website that allows you to, but has some kind of interactive feature that you need to navigate in order to download the data. So for example, let's say you're going to a website and you needed to download CSV files repeatedly by clicking on a download data button, right? If the CSV was hosted as part of the URL, the thing we all put into our web browsers, we could simply scrape that, get all the CSV. That would be great. But very often on a lot of websites, you'll have to interact with the website in some way to produce the data that you want. And so what browser automation can do is, say, for example, read in a list of different websites, maybe that have different URLs at the end. If you're looking at, say, different countries, and each country has a CSV and you want to download each one, you can then send instructions to Selenium about which URL to put into your browser, and then tell Selenium which part of the web page to click in order to download the data that you might want. And so to do that, I recommend this software Selenium. The R version is called R Selenium. There's also a Python package. You may need to consult this tutorial to get up and running, and you will also need to install Docker, which helps you create the virtual instances you'll need to run Selenium using my code. You'll also need to run the system command from your R code editor or from your terminal, if you're familiar with Bash, in order to install R Selenium within Docker, which is the virtual machine tool that we're using. And then in our Selenium, we need to essentially create a new object. Here we've called it RD for remote drive, and a new client, which is Selenium speak for kind of like a new browser instance. And then once we've done that, there are a suite of commands that we can index using this operator to different places. So if I wanted to visit the duke.edu webpage, once I've loaded up my browser, if you were running this code, you would see much like a player piano, like pianos that play themselves. You've all seen these. It's kind of like that. A browser opens, and then all of a sudden you see typing coming in up into the URL, and the browser begins to navigate to the page. And then if you use tools like this, we can use the CSS selector to navigate to the part of the page that we want to press or enter text into. And so we'd have to use one of the aforementioned techniques to find that part of the page that we want to interact with. And then we can pass arguments into this find element function, which helps us find the part of the web page that we might not want to navigate, and put in some type of code. So here it might be hit enter or click the mouse or something like that. And here we are, we're searching the Duke web page for mentions of data science, and this here refers to the keystroke for hitting enter. So literally, we're opening a browser, we're sending it to duke.edu, we're telling it to put the cursor on the search bar, we're telling it to put in write in data science, and then we're telling it to hit enter, and then we get some type of data. Now, quite obviously, if you're using screen scraping, you're doing it because you want to somehow iterate this process, do it again and again and again. And so you likely want to create some type of loop if you're doing this. Here's an example of a kind of template example of what some screen scraping might look like. If you are new to R, if you are new to open source programming, this may be a little intimidating. Essentially, what we are doing is giving our console here a list of websites. Then we're creating a place to store the data that we're scraping out of those websites. We need to do that in our loops. And then we need to write some code that tells, that provides a set of instructions to be repeated within a for loop here. And we're telling R to do this for a number of times that mirrors the length of the number of things we want to scrape. And then we simply pass all the types of code that we used in earlier steps to extract the data that we want, and then we bind that data together using, in this case, the rbind function. And then we do that again and again. And that's the basics of a simple, though I think non-functional code. Why is it non-functional? Because the Duke edu page and the pen.edu page have a different structure. So this is an example of how we'd have to have some kind of exception or if loop that told our code what to do if it encountered a Duke page versus a pen page, and then we'd have to kind of change things up. But that's the long and the short of it. When should you use screen scraping? I think this is the question to ask because, again, we're about to learn about what I think is a superior alternative. You should use screen scraping when you're encountering an older site. So many government sites still have an old structure that allows you to scrape them. Many universities have older websites that allow you to scrape them. And sometimes you will only want to navigate one page to figure out some feature of the page that then you're going to use to interact with in some other way for some other type of experiment or project. And learning how to navigate HTML is a kind of fundamental tool that you will likely run into sometime if you have not already. So although the uses of approved and legal uses of screen scraping are diminishing, there are still cases where it's good to know. And if you do use it to extract large amounts of information, be prepared again to do a lot of jujitsu with the web pages and custom kind of tweaking for the idiosyncrasies of each page. And you may also run into something known as rate limiting, which we'll talk about in a little bit, which means when you make too many repeated requests to a web page, you can get shut down by the server that hosts the web page or the web page itself. Okay, questions? We're behind schedule because of the AV mishaps, but are there questions here or on the live stream? If not, I think we should go ahead and take our break just so we don't get too far behind for the rest of the day. Tom, are there any questions?
Nothing.
Okay, good. So we'll be back, let's say 10 minutes. We had originally scheduled 15 minutes, but we lost about 10 minutes in our